Introduction to Automobile Engineering 1. Learning Objectives. At the end of this topic, you will be able to explain four-wheeler automobile, define chassis and power unit, describe four wheels drive, list out the types of automobile engines and cooling systems, describe the arrangement of valves. Outcomes. By the end of this topic, you will be able to understand the basic of introduction for automobile engineering, list out the various components of four-wheeler, list out the various components of the chassis, know the classification of chassis, have an idea about the types of automobile engines and cooling systems. Introduction. Automobile. An automobile is a self-propelled vehicle driven by an internal combustion engine and is used for transportation of passengers and goods on ground. Examples: bus, car, jeep, truck, tractor, motorcycle, etc. Components of four-wheeler automobile. Four-wheeler automobile consists mainly of two parts: 1. Machine portion, chassis and transmission, engine, electrical equipment. 2. Body or carriage portion. 1. Machine portion. Chassis. A vehicle without body is called a chassis. It is the backbone of the vehicle. All the moving parts of the vehicle are fitted to it. To give extra strength, it is provided with bolted, riveted, or welded cross pieces. It is now extensively used to denote the complete vehicle, except the body for the heavy vehicles due to its having a separate body. And it mainly supports body, engine, transmission system, includes frame, steering system, spring and shock absorbers, brakes, tires, wheels, etc. Transmission. The gears that transmit power from an automobile engine via the drive shaft to the live axle, and also it mainly consists of clutch, gearbox, universal joint, final drive, axles. Engine. It is the source of power. An engine consists of the following four basic systems: fuel system, ignition, lubrication system, cooling system. Electrical system. The battery, dynamo, alternators, ignition starting and lighting system. Chassis. It is the backbone of the vehicle. A vehicle without body is called chassis. The components of the vehicle like power plant, transmission system, axles, wheels and tires, suspension, controlling systems like braking, steering, etc., and also electrical system parts are mounted on the chassis frame. It is the main mounting for all the components, including the body, so it is also called as carrying unit. The shape of the chassis is determined by location of the power unit, the arrangement of the suspension system, and the loads to be carried. The function of the chassis is to act as the frame or skeleton of the vehicle, providing a mounting for all other assemblies and keeping them in correct relative positions in spite of all the varying loads to which they are subjected. Main components of the chassis. Frame. It is made up of long, two members called side members riveted together with the help of a number of cross members. Engine or power plant. It provides the source of power. Clutch. It connects and disconnects the power from the engine flywheel to the transmission system. Gearbox. The shell, metal casing in which a train of gears is sealed. U-joint. It consists of a pair of hinges located close together, oriented at 90 degrees to each other, connected by a cross shaft. Propeller shaft. The shaft that transmits power from the gearbox to the differential gear. Differential. A differential consists of one input, the drive shaft, and two outputs, which are the two drive wheels. However, the rotation of the drive wheels are coupled by their connection to the roadway. Functions of the chassis frame. To carry load of the passengers or goods carried in the body. To support the load of the body, engine, gearbox, etc. To withstand the forces caused due to the sudden braking or acceleration. To withstand the stresses caused due to the bad road condition. To withstand centrifugal force while cornering. Classification of chassis. 1. According to its control. A. Conventional chassis. B. semi-forward chassis. C. Full forward bus chassis. 2. According to the fitting of engine. A. Engine at front. B. Engine fitted at the center of the chassis. C. Engine fitted at the back. 3. According to wheel base size. 1. According to its control. A. Conventional chassis, in which engine is fitted in the front of the driver's seat or driver cabin. B. Semi-forward chassis. In this model of chassis, half portion of the engine is outside the cabin and the remaining in the driver cabin. In this arrangement, a part of the chassis is utilized for transporting extra passengers. C. Full forward bus chassis. Complete engine is mounted inside the driver cabin. Driver's seat is just above the front wheel. 2. According to the fitting of engine. Engine at front. Conventionally, the engines are fitted at front and drive is given to the wheels from the rear. Advantage: enough space is available for luggage behind the rear seat. The weight of vehicles is well balanced. Improved efficiency of cooling system. Engine fitted at the center of the chassis. In this case, the engine is fitted at the center of the chassis. This arrangement provides full space of chassis floor for use. Engine fitted at the back. Propeller shafts are eliminated. Center of gravity lowered due to elimination of propeller shaft, giving stable driving. Better grip on road, especially when climbing hill. 3. According to wheelbase size. In the long wheelbase chassis vehicle, wheelbase is the distance between the centers of the front and the rear wheels. The distance is more, thereby providing more floor area of the chassis for passengers and goods. In this type of chassis, the front overhang and particularly the rear overhang are also more. 2. Body. It is the superstructure of the vehicle. The chassis and body make the complete vehicle. The body of most vehicles should fulfill the following requirements. The body should be light. It should have minimum number of components. It should provide sufficient space for passengers and luggage. It should withstand vibrations while in motion. It should offer minimum resistance to air. It should be cheap and easy in manufacturing. It should be attractive in shape and color. It should have uniformly distributed load. It should have long fatigue life. It should provide good vision and ventilation. Power unit. Power unit consists of an internal combustion engine. It is usually mounted at the front end of the automobile. The clutch and the gearbox are placed immediately behind it. The three components, engine, clutch, and gearbox, are assembled into a single unit. Power transmission. Front engine, rear-wheel drive. In this layout, a front-mounted engine, clutch, gearbox unit drives a beam-type rear axle suspended on leaf springs through a propeller shaft with two universal joints. With the help of coil springs, the front wheels are independently sprung. This layout is one of the oldest layouts which remained unchanged for many years. Advantages of front engine rear-wheel drive. Reasonably balanced weight distribution between the front and the rear wheels, providing good handling characteristics. For easy front wheel steering movement, the engine occupies the reduced width between the arches. Behind the rear seats, large luggage space is available, and it provides increased carrying capacity as well as space for easy body movement. Accessibility to various components like engine, gearbox, and rear axle is better in comparison with other layouts. The control linkages such as accelerator, choke, clutch, and gearbox are short and simple. Full benefits of the natural air stream created by the vehicle movement is taken by the forward-facing radiator and reduced power losses from a large fan. Rear engine, rear-wheel drive. This arrangement eliminates the necessity for a propeller shaft when the engine is mounted adjacent to the driven wheels. The engine, clutch, gearbox, final drive form a single unit in this layout. In order to reduce the overhang distance between the wheel centers and the front of the engine, the final drive is generally placed between the clutch and the gearbox. Advantages of rear engine rear-wheel drive. A. It has a simpler drive shaft layout in comparison to front-wheel drive. B. The weight of the rear engine on the driving wheels provides excellent traction and grip, especially on steep hills as well as when accelerating. C. Effective rear wheel braking is possible with this layout. D. Due to the absence of the propeller shaft, the hindered floor space is reduced. E. The front of the vehicle can be designed for good visibility and smooth airflow. F. The exhaust gases, fumes, engine heat and noises are carried away from the passengers. G. This drive arrangement results in compact layout and short car. Disadvantages. A. It has a restricted luggage compartment due to narrow front, which houses the fuel tank too. B. Natural air cooling is not possible. It requires a powerful fan. C. Long linkages are required for the engine, clutch and gearbox controls. Front engine, front-wheel drive. No propeller shaft is used in the front engine front-wheel drive, and differentials are included in the same assembly. This layout provides optimum body luggage space and a flat front line resulting in a transverse longitudinal engine position. Good road adhesion is provided by the large proportion of the vehicle's weight acting on the driven wheels. Advantages of front-engine front-wheel drive. As compared to rear-wheel driven car, this is faster and safer traveling due to good road holding. Good road adhesion is obtained due to a large part of the vehicle's weight being carried on the driving wheels under normal conditions. Under steady conditions, generally preferred by many drivers, are promoted by this type of drive. Lower flat floor line is provided due to dispensing with the propeller shaft, resulting in the lowering of the center of gravity. The engine clutch, gearbox, and final drive are combined similar to the rear engine car. This provides a more comfortable drive due to final drive spring. Disadvantages. Due to the combination of steered and driven wheels with short shafts, special universal joints and a more complicated assembly are required. Four-wheel drive. To increase maneuverability of the vehicle required to travel on rough, unconstructed roads and trucks, another arrangement known as four-wheel drive is provided. Due to all the four wheels getting driven, whole weight of the vehicle is available for traction. But this advantage is not worth the additional cost on good road surfaces. The system is provided in Jeeps, which are known as 4x4 wheel drive vehicles. Advantages: four-wheel drive. Improved traction and handling, able to transmit more power to the wheels. Disadvantages: higher initial cost and weight, requires special service and maintenance. Types of automobile engines. Engines are classified according to number of cylinders and arrangement of valves, types of cooling, number of strokes, types of fuel burnt, method of ignition, firing order. Number of cylinders: single cylinder, multi-cylinder. Single cylinder. A single-cylinder engine is a type of combustion engine that features only one cylinder or chamber in which a piston moves to engage combustion. This is the engine's source of power, and since only one piston is doing the work, a single-cylinder engine is primarily used on smaller vehicles. It can produce a relatively large amount of power given its size, though the single-cylinder engine is not specially adept at varying the power output quickly, making it less versatile for larger vehicles. These engines are lightweight and compact, making them a good choice for engine-powered. Multi-cylinder. Multi-cylinder engine is a type of combustion engine that features multiple number of cylinders. In order to provide larger power, better balance, smaller size, reduced overall height, and the purpose of even torque, it would be used. Some of the few multi-cylinder engine types have been shown in the figure. Arrangement: inline, V-type, radial, opposed cylinder, opposed piston. Inline engine. Four-cylinder inline engine is also called as an overhead valve engine. It has engine with one cylinder bank. All the cylinders transmit power to a single crankshaft. V-type engines. V engines have two banks of cylinders inclined at an angle to each other with one crankshaft. Radial engine. More than two cylinders in each row are equally spaced around the crankshaft, opposed cylinder engine. Two cylinder blanks located in the same plane on opposite sides of the crankshaft. It has advantages of single crankshaft. Opposed piston engine. Single cylinder houses two pistons, each of which driving a separate crankshaft. It has the advantage running no cylinder head. Arrangement of valves. L-head. The intake and the exhaust valves are both located on the same side of the piston and cylinder. The valve operating mechanism is located directly below the valves, and one camshaft actuates both the intake and the exhaust valves. T-head. The intake and the exhaust valves are located on opposite sides of the cylinder in the engine block. Two camshafts are used to operate the valves, one for inlet and the other for exhaust. The valves are operated by the tappet directly. Each requires their own camshaft. Example Ford. F-head. The intake valves are normally located in the head, while the exhaust valves are located in the engine block. The valves are operated by single camshaft. The intake valves in the head are actuated from the camshaft through tappets, push rods, and rocker arms. The exhaust valves are actuated directly by the tappets on the camshaft. Example, Mahindra Jeep CJ 3V model. I-head. The intake and the exhaust valves are both mounted in a cylinder head directly above the cylinder. This arrangement requires a tappet, push rod, a rocker arm above the cylinder to reverse the direction of valve movement. The valves are operated by a single camshaft through the tappet, push rod, and rocker arm mechanism. It was rapidly superseded by the overhead camshaft. Example Ambassador, Ashok Leyland. Types of cooling. There are two types of cooling systems. 1. Air cooling. 2. Liquid cooling. Air cooling. Air cooling is a standard method of system cooling used to dissipate heat. The object being cooled will have a flow of air moving over its surface. Most air cooling systems use a combination of fans and heat sinks with exchanges of heat with the air. Liquid cooling. The normal cooling system used on most cars and trucks to keep the temperature of the engine down to a desirable level. Engine heat is removed via water acting as a coolant, which surrounds the cylinders in the water jacket. The system typically includes water passages, coolant pump, and thermostat. Summary. Let's summarize. The components of the vehicle like power plant, transmission system, axles, wheels and tires, suspension, controlling systems like braking, steering, etc., and also electrical system parts are mounted on the chassis frame. Four-wheeler automobile consists mainly of two main parts. 1. Machine portion, chassis and transmission, engine, electrical equipment. 2. Body or carriage portion. A single-cylinder engine is a type of combustion engine that features only one cylinder or chamber in which a piston moves to engage combustion. Multi-cylinder engine is a type of combustion engine that features multiple number of cylinders. There are two types of cooling systems: air cooling, liquid cooling.